Welcome to Ask and Learn.
Hi all, Alex B here with another question on electric current and resistance from Chapter 25 of Giancali's Physics for Scientists and Engineers. So part A of this question asks us to find the electrical resistance and current of a light bulb, which is rated at 75 watts when plugged into a 110 volt socket. So if you watched my last video, you know that we need two equations here. One is the equation for power, which I always remember as P is equal to IV. P being a power, a measure of energy per unit time. I being a measure of charge per unit time, and V being a measure of energy per charge. And then we always have our trusty Ohm's law, V is equal to IR. Rearranging these, you can say that I is equal to V over R, and plug that back in over here to find that P is equal to V squared over R. Or alternatively, we can rearrange that to find that R is equal to V squared over P. Plugging in the numbers that we're given, we know that we have V is equal to 110 volts and P is equal to 75 watts. So plugging that in, we find that R is equal to 110 squared divided by 75, which should give us 160 ohms, where here I'm using two significant figures because that's the number used in the problem. Now the current is actually a little bit easier because we can just go ahead and directly rearrange this equation up here, finding that I is equal to P, the power, divided by V, the voltage, which is just going to be 75 divided by 110, which is going to be about 0.68 amps. Or again, here I'm using two significant figures because that's the number used in the problem. Now, part B asks us to go ahead and solve the same problem, only this time with the power of 440 watts. With the same voltage V being 110 watts. No, sorry, 110 volts. Using the same equation as before, R is equal to V squared divided by P, should give us 110 squared divided by 440, which is going to be about 28 ohms this time. So again, we see that the lower resistance is actually associated with a higher power. And for the current, we're again calculating I is P divided by V, which here is going to be 440 watts divided by 110 volts, which should give us exactly 4.0 amps, which is going to be more current, which is what we expect when we have more power.